First thing we need to do for the long division is remember this setup. So inside the box, we want to put our numerator, and outside the box is going to be our denominator. So in this case, I know I'm going to have x plus 2 out here. But before I plug it into my box inside, I need to make sure that it's in standard form, meaning from highest exponent to lowest. And in this case, I went from 3 to 1 to none. So it's in standard form. However, step 2 says to fill in any zeros. If you recall from the notes up above, we need to make sure that every exponent is accounted for. So what I'm noticing here is I have a 2x cubed. I have no x squared, so I need to add in a 0. I have an x to the first and then my constant. So if anything is missing, even the constant, even if this had been missing, I would throw a 0 in there. Once that's accounted for, I put it inside my box. So I know I'm going to have 2x cubed plus 0x squared minus 5x plus 3. Okay, so my setup is complete. Now the division starts. What I need to do, similar to the long division with numbers, is I'm going to divide in just to the beginning of the polynomial. When I divided 12,345 by 8, I was able to divide 8 into 12. The other thing I need to keep in mind is when I'm dividing, I'm really only dividing in by that first piece of the divisor. So, x goes into 2x cubed. How many times? So this brings us back to the other refresher. When I was doing division with exponents, the rules are to subtract your exponents. So 2 divided by 1 is 2. X cubed divided by x to the first becomes x to the second. So this right here is what's going to go up on top as part of my quotient. And we want to line it up on top of the x squared. So I have 2x squared for my first piece. The next step is to multiply through. When I'm multiplying through, I need to multiply the entire binomial there. So I'm going to do 2x squared times x plus 2. This is the only time where the plus 2 comes into play. So I'm going to do 2x squared times x. That's going to give me 2x to the third. And I'm going to do 2x squared times 2, and that's going to give me 4x squared. Okay. Now, at this step, we should be seeing the terms, one on top of the other. That very first term should cancel out. It needs to be exactly the same if we did our division properly. In this case, the 2x cubes match up. So now what do I need to do? The next step in long division is to subtract. But what I need to do is subtract an entire polynomial. Well, our most recent lesson on subtraction of polynomials said, when I have that, I want to change the signs and add. So I'm going to have make this a little bit brighter. I'm going to change this to addition of 2 negatives. So the 2x cubed became negative, the 4x squared became negative, and now at this stage I'm going to add straight down. So back in here. So the 2x cubed canceled because I had a positive and a negative. 0x squared plus a negative 4x squared gives me negative 4x squared. Okay, what's my next step? Next step is to bring down the next piece, just like I brought down the next integer in the long division, or the next digit. And here I go again with the division process. So let me clear my workspace. What I want to do next is divide again. So I'm going to divide negative 4x squared by the x. Well, I write that out. Negative 4x squared is being divided by x. That will give me negative 4x to the first. Exponent there. That's the piece that goes up for my next term. I should line it up right above the x term on the top of the box. Now, following the same procedure, I should have to multiply. And again, when I multiply, I'm multiplying through. So negative 4x is being multiplied through the entire binomial, negative 4x times x plus 2. Here we go. When I multiply, I need to distribute, so I'm going to have negative 4x squared. And my second term will become negative 8x. That's what's going to go directly below what I just divided. Okay, so I did the multiplication, I wrote down underneath. Again, my next step now is to subtract. And when I subtract, I need to change my signs. So this is going to become addition, change that sign, change that sign. And now I add straight down. Remember, we're not subtracting polynomials. We are doing our first step of changing all the signs and then adding. So my 4x squared term cancels. Negative 5x plus 8x gives me a positive 3x. And I have one last term to drop down, which is a plus 3. And I'm going to start that process one more time. And since there's nothing left to drop down at that point, that will be my last piece. So I'm doing the same process over and over again. I divide the lead part, the x, and I'm dividing 3x by x this time. So 3x divided by x should give me just 3. Well, that's a nice number finally. So I'm going to bring my quotient up there to 3. I'm now going to multiply the 3 all the way through, and that's going to give me 3 times x plus 2. So I'm going to distribute. I get 3x, distribute again, and I get plus 6. That goes right below 3x plus 6. My next step, remember, is to subtract. But, as talked about multiple times, we don't do subtraction with polynomials. We change to addition of the opposites. And now I just add straight down. So the 3x term cancels. 3 plus a negative 6 gives me a negative 3, which is my remainder. Since there's nothing left to drop down, that will be my remainder. So the answer to the entire quotient, or the quotient to the original division problem, is going to be 2x squared minus 4x plus 3, remainder of negative